Okay, so our t is the number of years after 2000. Now what will be t for 2000? T is the number of years after 2000, and if we are taking 2000 years, our t is 0, right? So when we have t 0, 282 million is the population. And what is the t for the year 2020? 20. So when the t is 20, our population in millions is 335. Okay, so our target is, as I said earlier, our target is finding c and k. So from this model, so we know our p of t is c times e to the power kt. Okay, our target is finding this c value and finding the k value. Okay, now when our t is 0, so when t is 0, we know what is p of t, right? P of t is 282. Let's substitute this here. So when our t is 0, so let's substitute 0 for every t. When t is 0, we have c times e to the power k times 0. So when t is 0, so this is the function. Now what do we know about p of 0? What is p of 0? What is population when t is 0? 282, right? So 282 equals to c times, so e to the power k times 0 is 0, so e to the power 0 is 1. Okay, so our c is 282. Okay, we know what is c now. C is 282. Now we need to find k. So when t is 20, now let's substitute 20 for every t. So let's substitute 20 for every t in this function. So p of 20 equals to c times e to the power k, and t is 20. Okay, now what is p of 20? What is the population when the t is 20? It is 335, right? 335 million. Do we know what is c? We already know what is c. Our c is 282. So we substitute 282 for c, e to the power 20k. So here we are trying to find the value for k. Okay, now, so this is the exponential equation. So let's get rid of 282. So for this we divide both sides by 282. This 282, this 282 cancel. Now 335 divided by 282. Just let me leave this as it is. So 300, you can use calculator. 335 divided by 282 equals to e to the power 20k. Now how do we solve this? We can't make a same base, so we apply natural log on both sides. Okay, when you apply natural log, we can write this exponent in front of log. So we have ln of 335. This ln of this is number, okay, 282 equals to 20k times ln of e. So ln of e is 1. This is 1. Does anyone have a answer for ln of this number? What is the ln of? You must divide 335 by 282 first, and then find the ln of that number. Okay. 0.172. Okay, equals to 20k. Now we need to get rid of 20, so we divide both sides by 20. So this 20 cancel, and so do we have something like 0.00861 equals to k? Okay, so this is our k. Now let's substitute our c and k in our function. So our function is p of t equals to c is 282, e to the power k is 0.00861 t, and this is the function that help us to find the population. Now, is it a decay or growth? Is it exponential decay or exponential growth? It's a growth, right? We have this e, and our exponent is positive. So now this function, it helps us to find the population, okay, in every year. So this is for part A. Now in part B, it tells us to estimate the population in 2016. So we're going to use this function. Now year 2016 means what is the time? 16, right? Our t is the number of years after 2000. So 16 means 2016, okay? For 2016, our t is 16. Now you substitute 16 for every t in this function. So we have p of 16. P of 16 is equals to 282 times e to the power 0.00861 times 16. Now use your calculator and you will find the, so it's gonna be very close to 324 million, okay? So this will be the population in 2016, 324 million. Can you enter all these expression on your calculator? If you can just enter like everything on your calculator, okay? If not, you multiply these two number, then find e to the power of this number, okay? Then multiply with 282, okay? You have to do step by step. If you can't enter everything on your calculator, okay, you find e to the power of those number and then multiply by 282. Okay, the next is we need to find, we need to estimate for 2025. So what will be t for 2025 year? For 2025, our t is 25, right? It's the same process. You substitute 25 for every t. So p of 25 equals to 282 times e to the power 0.00861 times 25. Okay, now I need your help here. Can you give me the final answer? Yes.
350 million.
How much?
350?
Okay, we have 350 million. Okay, 350 million. So when in the year 2025, the population of the US would be 350 million. Does anyone know what is the current population of US? Okay, can you use your phone and help me? Let's see if this model is correct or not. Can you just Google it, the current population of US?
Current population is, what's from 2022?
In 2022 is 333 million.
So in the year, you said 2022 is?
333 million.
333 million. Okay, so in the 22, 333 million. Okay. Is it a good estimate? Like, is this function giving us a close answer? Now in 2025, do you think we will have like 20 more million population? Now let's find for 2022, okay? Do we get a, okay, now let's find for this year. So for 2022, our t would be 22, right?
340.
So we get 340. Oh, okay. So if you find p of 22, we get, how much you said, 300? 340 million. Okay. So this is the estimation that we made from the function, okay? And in the real population was 333, like 7 million plus, okay? So it still gives some number, okay? But it's not like 7 million difference. That's a huge difference, right? Now, so if this is the case, it means it's not a kind of like a good model. Like the function that we have, it's not a good model. So we have like a 7 million difference. That's a huge difference, right? So there is a model called a logistic model, okay, which we use for the population growth, okay. Now this function, it does not give us the good estimation. So they have a new model here which they call logistic model, okay. So logistic model, I'll just write on the function and the graph, okay? And this function is c over 1 plus 8 times e to the power minus bx. This is a function, so here a, b, c are a constant, okay? A, b, c are constant. So now just they use this model, okay? It means they use this function. And we need to find what are a, b, c, okay, from the data given to us. Okay, we can find that. And the graph of this function looks like this. So if we draw a graph of this logistic model function, we're gonna get the graph like this. So this is the graph for logistic model. So what was our function for this last example? We had a exponential growth function, right? So we had exponential growth means, so we had the graph looks like this. Now, why do you think that this was not good estimator from the graph? Can you say like why we didn't take this graph? That's right. Like if we go as the time increases, the population goes to the like a infinity, right? That's not possible. Okay. And there are like so many factors that determine the population growth. Okay. And because of that, we require a new model. We require a new function. And this is the new function that use, and the graph is this one. Okay. So the population is start, and at some point the population, there is a very slight increase. Okay. Or it remains, it doesn't remain exactly constant, but there is a very slight increase. So this is, so if you see this graph, so this is the logistic model. Okay. And you don't need to worry about just calculating ABC here. I'm just letting you know that the exponential growth is not the good model for population growth. Only for the population, we use the logistic model. Okay. So on your homework, I checked your homework, and every homework, like you have 17 to 20. These are just you are matching with a graph, so you can do this very easily. 21, 23, 25, and 27. I think you should be able to do with the help of these two examples. Okay. So try this. If you need help with the homework, we'll do on Monday. Okay. So let's do this much for today.